Today in this video I want to explain about the files that we have in this project. You would see a shared link that you have access to a OneDrive cloud, and within that folder you see these 5 files. First is a data folder which has the raw data. If you open it, you see I made an Excel file for each subject. So basically it has the raw data related to each subject. There is file prediction file, basically output of the R file, so I explain them later. Feature index is a data dictionary about the files that we have. Also there's another data dictionary related to box rate, like what each box rate means. Let me just make a wrap up about what we had in the previous session. Basically, the goal of this project is categorizing the people based on their intention to fatigue. Basically, which we want to see how we should assign works to the people based on their intention to fatigue. Some people might be more fatigable, somebody might be less. So one way is just doing time series clustering using the box rate. However, first of all, in real cases you have to hire someone to record the box rate by asking directly from the people. Also, in some jobs that needs a lot of safety and also the employees might be concentrated a lot, this approach is not applicable. So instead of doing box rate, we want to see if we use sensor data, could we achieve same performance or not, or could we use sensor data instead of interrupting the people and asking about the box rate or the fatigue level. Also, we know that in 18% of the time, as we see here, from time point 1 to time point 9, people doesn't show any sign of fatigue. Basically, since they just started the job, they may not see any fatigue. So we are not sure if doing data time series clustering from the first time points is meaningful or not, or maybe we should skip some time points and then do clustering. So it is another research question that we had. For this purpose, we did time series clustering starting from time point 1 as a new one scenario, starting from time point 2 to the end. Second scenario and the last scenario, which is starting from time point 9 and considering from time point 9 to the end and doing the clustering. So 9 scenarios. Also, not this file. Let me open. Okay. Also in that folder you see a write-ups, a draft. Let me just open it. So we have 9 scenarios starting from different 9 time points. Also, we know in time series clustering we have 2 other parameters, which is distance and central parameters. So at the end we have 9 times 9 times 5 different scenarios. We do time series clustering with box rate and sensor data, and then we want to check the overlap. How much sensor data has overlap with the box rate in terms of clustering, time series clustering, and categorizing people into 2 groups of less performance and high performance, or less fatigable and high fatigable. And at the end, we want to see if is it possible to use physiological data to predict the sensor data's cluster, because if they are predictable, we can do time series clustering and use those predictions to validate our time series clustering. Basically, we want to see how, if those predictions and time series clustering are close to each other, we can think that our approach is meaningful. So let's look. Let me just open another file, which is weekly IoT report -8-15-2018. And I go to a scenario from a starting time point 1. And when you open it, you might see different columns. Just disregard anything from C to L. These are just some other details. So I hide them and I just focus on A, B, M, N, O, P. You need to know some explanations about sensor data. Let me just open it. So Borg's rate is what we directly ask from people. It has ID 7. Time standard deviation ID 11. Distance standard deviation ID 13. Jerk average ID 19. And angle back ID 20. We want to see if it categorizes people with the sensor data. Does it have good overlap with the Borg's rate? If the cluster has good overlap, it means maybe in future, instead of interrupting people and asking about their fatigue, we can just use the sensor data and get some insights. Okay, let me go to a start time point 1. And this scenario we do time series clustering from a starting time point 1 to the end. The overlap between IT 7 and 11 in some cases might be even 100%, and some cases it's just 7%. IT 17 and 13. 13 was distance standard deviation. In some cases might be 87%, and some cases just 7%. So based on the distance and centroid parameter that you choose, the overlap of Borgs and sensor data might be different. Here I picked the best 5 overlap scenarios and did the average of them. I know I can pick some of distance and center parameter and make a good overlap with Borg and like sensor data. So overlap of 711, 713, 719 and 720 in best 5 scenarios. Also I look at the standard deviation of the differences, like let me just do it here. In overlap of 7 and 11, let me just show it again what the 7 and 11 means. 7 means Borg, 11 means time standard deviation. Borg is achieved by interrupting people and asking from them. 11, or these yellow ones, are sensor data. We just got it from sensor. So 75 is the average of these 5s, and 13 is just their standard deviation. And I did for overlap of 711, 713, 719 and 720. And same happened for starting from a starting time point 2. Let me just hide these columns. So I had different scenarios. In each scenario I might have different overlap between 7 and 7, which is Borg's rate, and 11, 13, 19 and 20, which are the sensor data, and these are the average of top 5, also the standard deviation of top 5s. Okay, let me just visualize it, all of them in one figure. As you see here, these are this figure shows the average of top 5s in different starting time point. As you see, there is no evidence if you pick skip some points and do the clustering, it makes a lot of differences. So if I start from time 2, 6, 7, 8, 9, maybe at the end the overlap between Borgs and sensor data might be very similar, although for jerk you might see there's high deviation of overlap between jerk rate, peak jerk mean, which is sensor data, and ID7, which is Borg's rate. So for us, just assume that starting from time point 1 makes sense, and we stay with that. So just let me go over the R code and see how we make this up to here. How I make these sheets, start 1, start 2, start 3, start 4. If you go in that folder, you see the RMD, which is the R file, and its session file, which is next to it. Basically, the session file, which is .r data, it just saves all of outputs and merge it into a file. But RMD is just R file which has the scripts. This file has 4 sections. Section 1 is for defining the function that I use. Section 2 is for bringing the data, the raw data that you might remember. But if you want to run by yourself, you should change the addresses. So I use the address that I use in my computer, but you might change the address. The save folder is basically the major folder that you have for saving and recording your data. Third part is binomial time series clustering. Basically, as you see, there is section start underline t and is equal to 1. Basically, do a clustering from a starting point time point 1. In this section, it prepares the data from the raw format to time series format. In this one, it does time series clustering, and it records the files. Let me just load the data. Also, you see there's something like T1 underline perf. If I open it, this is the Excel file that I just showed it to you. So T1 underline perf basically is this Excel file starting from time point 1, and it shows the overlap of the Borgs and sensor data. And same for other T2, T3 underline perf up to T9. So we stay with the starting from time point 1, and we want to see if we can do use the physiological variables of subjects to and use them for predict the classes labels that we already did in the previous section. So let me go to this. So I use support vector machine, logistic, neural network, and tree-augmented naive-based algorithm to predict the labels of top 5 scenarios in the previous section. I use them, and as you see here, the performance is not that much great. Like for time standard deviation, LR stands for logistic regression, accuracy 60%, 0 sensitivity, specificity is 81, and AUC 95.5. Almost in all of them, the performance of those models in predicting the labels is too bad. This is it. This table shows the average of all of them. So basically, this table down here is just average. It just summarizes all of these 4 tables above. How we can achieve these tables? You go to R files and do like this section is for clusters of sensor data that has label 11. Label 11, as you might remember here, was for time standard deviation. Okay, so since the performance was bad, like for prediction 11, sensor code 11, 13, 19, and 20, for all of them we couldn't predict the labels very well. So I use ensembling. Basically, I stack out the probability predicted in each algorithm and insert them as a new independent variables into a random forest, trying to predict the labels. Actually, I tried different ensembling, like ensembling with SVM, logistic, random forest, and neural network. I already used logistic regression in the previous prediction, so when I want to do ensembling using logistic regression, I don't use logistic as an independent variable. The outcome of logistic probability is as the income. Like again, like if I want to do stacking using neural network, I didn't use outcomes of neural network as an input in the model. I just did for checking if my ensembling algorithm works. But at the end, I used this one, ensembling using RF, which stands for random forest. My inputs are the probabilities predicted with logistic, SVM, neural network, and TAN, and then I look at the performance. Also, I did the same thing for sensor 13, which is distance standard deviation, sensor 19, which is jerk standard deviation, and sensor 20, which is angle back. First, I try to predict the labels using logistic, SVM, neural network, and TAN. My prediction performance was bad, so I did ensembling using leave out algorithm, and I ensembled them through a random forest algorithm. So again, first I try to predict the sensor data's clusters label using support vector machine, logistic, neural network, and T-Rockman naive Bayes. The performance was bad. I used these predicted probability as input into a random forest, and basically I used a stacking algorithm. But since the number of my data was low, I used leave out algorithm or method. Basically, each time I predicted label for one subject using 14 subjects. It sounds I had 15 fold cross validations. Each of folds 14 was trained, 1 was predicted. When I did that, basically I could predict all of the clusters correctly, 100% accuracy. It might be strange for you, but actually I tried over Python. Basically, I did all of my coding with Python too. At least I tried with Python to validate my outcomes. And I have one colleague here, Ali Reza Farnoosh. We did some of them together actually. So two guys did algorithms to be sure. So it's not just I did by myself. I did different ways to validate my outcomes. Anyway, if I use a stacking algorithm and leave out approach, I can predict all of the census data cluster correctly. I just forget to say one more thing. So you know that I used all of the data starting from time point 1 to the end. I used sensor data clustering. Basically, if I picked the first top 5 algorithm which has the highest overlap of Borg's rate and sensor data. So, you know, 5 different scenarios. Let's say I want to use these type 5 scenarios for sensor 11, which is time distance, time standard deviation. These are the labels created with each scenario. Like, let me just maximize it. Mean DTW. Mean is a centroid parameter, DTW is distance parameter. Mean LBI. Mean is centroid parameter, after underline is distance parameter. So I know this is one of my best algorithm, and at the end I picked the first top 5 scenarios that has the highest overlap of Borg's and sensor data, and I did based on majority voting, and I voted the clusters label based on the majority of votes. Like here, let's say for subject 2, 5 scenarios said it's label, 3 scenarios said it's label 1, 2 said it's label 2, so 3 out of 5 said it's 1, so the label would be 1. And I did for ID 11, 13, 19, and 20. So basically what at the end I'm predicting these columns, which is majority votings of the label's name. And as you saw, I could predict the census data clusters in type 5 methods with 100% accuracy, or I could predict all of them correctly. That was for today. I'm sharing this video over YouTube. Also, I'm sharing the folder's name, the folder's location, so you can access to it, to these write-ups, coding, Excel file, or raw data. Thank you very much and have a great day.